This last video for the course is a very short video because we're not going to do much with Markov chains except, give you a chance to see them and work with them. And basically, it's kind of taking some of the things that we kind of did with probability and actually working some matrix stuff into it. So I think that's the reason why they want it covered in this course. And of course, it's also required that I have to put a problem on the final that has one in it. Um, so let's have a look at this. Basically, Markov chains deal with what they call transitional probabilities. And basically, you start with some preceding stages. You're given some information about like what's happened beforehand, and you're looking at a transition that's happening between a split group. And it's based off of what happens at the preceding stage that's going to happen in the future stages or the current stage, and you can predict what kind of is going to go on as if time goes on and the trend continues. The outcome of any stage of the experiment is called a state. The outcome at the current stage of the experiment is called the current state. So, for instance, here's an example of a type of problem that you would tend to see for this example. Morris Polling conducted a poll 6 months before an election in a state in which a Democrat and a Republican were running for governor and found that 60% of the voters intended to vote for the Republican and 40% intended to vote for the Democrat. In a poll conducted 3 months later, it was found that 70% of those who had earlier stated a preference for the Republican candidate still maintained that preference, whereas 30% of these voters now preferred the Democratic candidate. Of those who had earlier stated a preference for the Democrat, 80% still maintained that preference, whereas 20% now preferred the Republican candidate. You're asked two questions here. If the election were held at this time, who would win? And assuming that this trend continues, which candidate is expected to win the election? So we're looking at this poll 3 months later is happening now. So we had 6 months before, we have 3 months after that, which is now, and we have the election, which is another 3 months in the future. That's what's going on here. So focusing our attention on A, we're just going to look at if the election were held at the time of this poll, with the information that we were given, who would be winning at this point. And so what I'm going to be doing here is using what they call a transition matrix. A transition matrix is associated with Markov chains. It's an n by n matrix. And basically each of these are going to be probabilities that are more than 0, and the sums of the entries in each column has to be 1. So as I go down each column, it has to be 1. So when I look at what's going on here, I need to come up with a matrix that represents my current data, my current state, and I need to come up with a transition matrix that's going to help me get to the next state. So originally, we had a split of 40% to 60% for Democrats and Republicans, respectively. And then, based on the description, those who voted Democratic, 80% still vote Democratic, 20% still vote Republican. For those who were voting Republican before, 30% have changed to Democrat, 70% stayed Republican. So when I set up my current state, I'm going to set up a 2-by-1 matrix, which is 0.6, 0.4, with the number of Republicans on top, or the percentage of Republicans on top, and the percentage of Democrats on the bottom. When I set up my transition matrix, here's where these numbers are coming from. When I read this here, this is where they started. They started Republican, they started Democrat. So this column here is they started Republican, stayed Republican, 70%. Started Republican, went to Democrat, 30%. Started Democrat, turned to Republican, 20%. And so forth. So you can see where this is coming from. The columns have to be the ones that total 1. That's the important thing. So basically, to find out the current state, with these numbers being told to us, where are we now as far as the state of the voting preferences going to? So I1 is going to be calculated by me taking the transition matrix times I sub 0, which is our starting state, our initial state. Sub-zero is, I mean, a subscript of 0 usually means initial in most math and science texts. So I'm going to take, basically this transition matrix times this state matrix, multiply them together, and what I get is a 2 by 1 matrix, which is 0.5, 0.5. And on top, it's still going to be the Republican percentage. Second one's the Democrat. So based on this result, if the election were held today, it would be an even split with each candidate with about 50% of the vote. So, with these things being true, the way they're being stated, that's where I expect things to be. Now, for part B, when it asks the question, okay, well now, assuming that this trend continues, which candidate is expected to win the election? Well, since this is another 3 months, I mean, the first state went from, and you want to make sure that for the trend to continue, you have to make sure that the period of time is the same. Since it started 6 months before, and then today is 3 months before, and then on the election day will be 3 months later, it's still going, the span of time is still the same. So this span of time is still allowed to continue, and assuming this trend continues, on election day, I would expect the results to be reflected by the stage 2. And stage 2 would be me taking the transition matrix times stage 1. So I'm going to take that transition matrix again, which I had before. I'm going to take it to the answer I got in part A. So this is the state we were in part A. I said stage before, it's state. And if I multiply those together, I get 0.45, 0.55, with the 0.55 going to the Democratic candidate. That means if this trend continues, the Democratic candidate will win the election with 55% of the vote when election day comes around. So there's an example of a Markov chain. You do have a couple examples in your homework involving it, so work through that and we'll talk about them in class. But until then, have a good day, and I'll see you in class.